The ocean is one of the few places on Earth that can look peaceful and threatening at the same time. From far away, it seems open, flat, almost endless. A blue surface stretching under the sky, but then the horizon changes. A line darkens. The water lifts higher than everything around it, and for a few seconds the sea no longer looks like something you cross. It looks like something standing in front of you. That is the mystery of the ocean wall. Not every wall of water is the same. Some are born in storms. Some appear without warning in the open sea. Some rise when waves strike reefs, cliffs, or shallow ground. Some begin as ice falling from a glacier. And some exist where the human eye can see nothing at all, hidden beneath the surface in layers of heat, salt, and density. So the real question is not just how big can a wave become. The real question is, what makes the ocean suddenly rise like a wall? To understand that, we have to start with something simple. A wave is not just water moving forward. Most of the time it is energy moving through water. Wind drags across the surface. At first it makes tiny ripples. But if that wind keeps blowing across a long enough stretch of ocean for long enough time, the ripples grow, they organize, they stretch, they become swell. The ocean remembers that energy. A storm may be hundreds or even thousands of miles away, but the waves it creates can travel far beyond it. By the time those waves reach a ship, an island, or a coastline, the sky above may look calm. The danger can arrive without the weather that created it. That is one reason the sea can feel so deceptive. A wave is not dangerous only because it is tall. Height is what the eye notices first, but weight is what delivers the impact. A wall of water is not a curtain. It is a moving mass shaped by gravity, speed, pressure, and the energy stored inside the swell. When that mass hits a ship, a cliff, a seawall, or a reef, the softness of water disappears. It becomes force. This is where the first kind of ocean wall enters the story, the road wave. For centuries, sailors described waves that seemed too large to be real. Walls of water rising out of rough seas, sometimes from an unexpected direction, sometimes without a dramatic warning. For a long time, stories like these sounded like ocean legend. But rogue waves are real. A rogue wave is not just a big wave. It is a wave that is dramatically larger than the waves around it. It breaks the pattern. One moment, the sea has a rhythm the crew can read. The next, one wave rises above that rhythm and turns the horizon into a vertical threat. The frightening part is not only the size, it is the timing. Ships can be built for heavy seas. Crews can study forecasts. Captains can adjust course, but a steep wall of water arriving from the wrong angle gives very little room for negotiation. If the bow cannot climb it, the wave does not simply pass, it hits. And when a rogue wave strikes, it transfers energy into the hull like a moving cliff. Windows can shatter. Deck equipment can be torn away. A vessel that looked massive from shore can suddenly feel small in the open ocean. But rogue waves are only one version of the ocean wall. In storms, the sea changes in a different way. A storm does not usually create one perfect monster wave. It builds a whole moving field of unstable water. Wind pushes the surface, pressure changes the water level, rain reduces visibility, waves cross, merge, break, and rebuild. The ocean becomes less like a pattern and more like a machine. In that machine, the danger is repetition. One wave may be survived. The ship rises, drops, shakes, recovers, but then another arrives. And another. Each impact comes before the last one has fully left the body, the vessel, or the coastline. This is why storm waves can feel like siege. The ocean is not attacking once. It is returning again and again. Near land, storm energy can create something even more frightening, storm surge. This is the moment the ocean does not just rise upward, it moves inward. During powerful storms, winds can push seawater toward the coast, raising it above the normal tide. The sea crosses boundaries people thought were stable. Harbors, roads, homes, seawalls, and city streets become part of the shoreline. And storm surge proves something important. An ocean wall does not always need to look like a curling wave. Sometimes it is a wide, rising mass of water with no dramatic crest at all. It can move slowly compared to a breaking wave, but it carries the weight of the sea into places built for land. This is one of the most dangerous misunderstandings people have about ocean walls. They imagine a single wave, but sometimes the wall is the entire water level rising. Now, not every giant wall of water is caused by wind. Another kind of ocean wall begins when the ocean is suddenly displaced. That is the basic idea behind a tsunami. A tsunami is not like an ordinary wind wave. It can be triggered when an earthquake, landslide, volcanic eruption, or another sudden event moves a huge volume of water. In deep ocean, it may not look like a towering wall at all. It can pass beneath ships as a long, low wave. But when it reaches shallow coastlines, everything changes. The wave slows. The water behind it keeps coming. The energy compresses. The sea can rise, flood, surge, and push inland with terrifying force. This is why the word wall can be misleading. The ocean does not always stand up neatly. Sometimes it piles forward. Sometimes it climbs the land. Sometimes it becomes a fast-moving flood full of debris, pressure, and unstoppable momentum. But here's the thing. The ocean does not need an earthquake, a hurricane, or a legendary rogue wave to become dangerous. Sometimes the wall is created by the shape of the seafloor itself. When deep-water swell moves toward shallow water, the lower part of the wave begins to feel the bottom. It slows down, but the upper part keeps moving. The wave becomes steeper. Its energy has less room to spread out, so it rises. This process can turn a smooth swell into a breaking wall. That is why reefs are so deceptive. From above, a tropical reef may look like paradise. Clear blue water, white sand, sunlight flashing across the surface. But just beyond the calm lagoon, deep ocean swell may be meeting shallow coral. The wave lifts, it hollows, it throws itself forward. A reef wave can look beautiful and still be brutal. Surfers may chase these waves because they form clean, powerful barrels. But the same shape that makes them perfect also makes them unforgiving. The water can break over coral that is sharp, hard, and close to the surface. A mistake does not end in deep water. It can end against the reef. Deep water becomes shallow. Beauty becomes danger. Paradise reveals its edge. At cliffs, the story changes again. A wave approaching a sandy beach can spend its energy gradually. It breaks, runs up the shore, and spreads out. But a cliff gives the wave no soft ending. The water hits stone. It compresses, rebounds, explodes upward, and falls back into the next incoming surge. At the base of cliffs, waves can collide with their own reflections. Water attacks the land, then returns and meets the sea again. That chaos can create sudden bursts of spray, violent currents, and waves that climb much higher than expected. This is why rocky coasts can be so dangerous even when they look safe between impacts. The sea may retreat for a moment. A ledge may appear dry. Then a larger set arrives, reaches farther, and erases the place where a person thought they were standing outside the ocean's reach. The wall was not gone. It was gathering. In polar regions, an ocean wall can begin in a completely different form. Ice, a glacier face, may stand quiet for hours, days, or weeks. It looks frozen still, almost permanent. But inside it, cracks are growing. Meltwater is moving. Gravity is pulling. The tide is working at the edge. Then part of the glacier breaks. When a huge mass of ice collapses into the sea, it does more than splash. It displaces water. Waves rush outward. Floating ice rolls. Small boats can be lifted, pushed, or trapped in sudden motion. In narrow fjords, the danger becomes even sharper. Steep rock walls can reflect and focus the wave energy. A wave born from falling ice or landslide can cross the water, rebound, and keep moving through a confined space. This is one of the strangest versions of the ocean wall because the wall begins as land. A frozen cliff falls and the ocean answers. But the most surprising ocean walls may be the ones no one can see. Beneath the surface, the ocean is not one simple body of water. It has layers. Warm water can sit above cold water. Fresher water can sit above saltier water. Differences in temperature and salinity change density, and density changes how water moves. These boundaries can behave almost like invisible walls. A submarine can pass from one layer into another. Instruments can detect sudden changes. Sound can bend. Currents can shift. Marine life can gather along these hidden edges because nutrients, plankton, and smaller fish often concentrate where water masses meet. And along those boundaries, waves can move underwater. They are called internal waves. To someone on the surface, the sea may look calm, but below, Giant waves may be traveling through layers of different density, rising and falling in the dark like mountains made of motion. This changes the meaning of the ocean wall. It is not only a visual event, it is a structure of energy. Sometimes it rises above the deck of a ship, sometimes it breaks on coral, sometimes it floods a street, sometimes it falls from a glacier, and sometimes it moves silently beneath the surface, shaping life without ever breaking into foam. For humans, every version teaches a different lesson. A sailor learns that size is not control. A cargo ship can be huge and still vulnerable to angle, timing, and impact. A fisherman learns that familiar water can turn quickly. A surfer learns that beauty and danger can share the same wave. A coastal family learns that the line between land and sea is not as permanent as it looks. Science helps. Forecasts, satellites, buoys, radar, tide gauges, sonar, and ocean sensors give us more warning than humans have ever had before. We can measure swell, we can model storms, we can map reefs, we can monitor glaciers and coastlines. We can learn the signs before the sea turns violent. But measurement is not command. The ocean does not stop building energy because we understand the equation. It does not flatten because a forecast exists. It does not ask whether a harbor, ship, road, or camera is ready. And that is why the ocean wall remains so powerful as an idea. It is not just a wave, it is the moment the ocean reveals what it has been holding. Wind becomes height. Distance becomes swell. Gravity becomes collapse. Shallow ground becomes a breaking point. Ice becomes displacement. Heat and salt become hidden borders. And water, the thing we think of as soft, becomes a moving force too large to argue with. At the beginning, the sea looked open and familiar. By the end, it looks different. Because the ocean is never just a surface. It is a deep system of energy waiting for the right shape, the right pressure, the right depth, or the right moment to rise. And when it does, the wall is not a monster from myth. It is the ocean being honest. If this journey changed the way you see the sea, subscribe to Verscope for more cinematic stories about the hidden forces shaping our world.